Sir. Welcome, sir. Dr. Sudhir Das, sir, is presently working as an assistant professor in Department of Computer Science and Engineering, NIT Warangal. He is awarded PhD from the Department of Computer Science and Engineering at NIT Durgapur. Dr. Das has 18 years rich experience in teaching along with 9 years experience in research with quality educator sector. He has published around 50 papers in the referred journals and conferences and scored 1,000 plus citations. He has research publications in prestigious journals like Applied Soft Computing, Neural Computing, and Applications, International Journal of Fuzzy System, Journal of Embedded Intelligent and Humanized Computing, Soft Computing, Journal of Intelligent and Fuzzy Systems. He is working as active viewer in many reported journals and conferences, achieved three conferences, Best Paper Awarded in CSO 2014, Beijing, FICTA 2015, Durgapur, and FRBS 2018, Kolkata. Dr. Das is a well-known resource person in the field of universal human values, UHV, which is required to nurture the human minds in order to bring the feelings of happiness in ourselves, our family member, and our society at the larger perspective. He has delivered a number of talks in universal human values in various workshops throughout the India. He has organized a number of faculty development programs, FDPs, and conferences. Moreover, he has chaired many sessions in the prestigious conferences. Uh, he has been delivered talks as invited speakers in many FDPs, seminars, and conferences. His research interests include fuzzy system, hybridized fuzzy subset, multi-criteria decision making, robust optimal solution using soft computing. AI, evolutionary computation, and machine learning. Welcome, sir.
Yeah, thank you, sir, for this nice and brief introduction.
Yes,
So really, it's a great opportunity for me to share my thoughts on this platform, on this AI applications for engineers. Really, I am thankful to the organizers of this FDP for inviting me to share my thoughts here.
welcome, sir.
Now, yeah. So now I will start my session. Just wait 1 minute. And so can anyone confirm, please, my screen is visible or not?
Visible, sir.
Okay, thank you. So today, our topic of discussion, this is fuzzy logic and applications. So this is the presentation outline of our today's discussion. And so I would like to request my participants so that they can ask me queries at any time. They can interrupt me at any time during my presentation. Also, feel free to raise your questions at the end of the session, whatever you feel like better. But I will be happy if you interrupt me during my sessions also. Yes, so initially, so I will tell regarding some introduction to fuzzy set and fuzzy logic. Then gradually I'll move to this fuzzy logic controller. Then we'll try to find out how to design a complete fuzzy logic based system. Finally, so we'll explain this Mamdani approach, that is the application area in mobile robot. So what is fuzzy? So actually, once we need to say that what is fuzzy. So if we find out online dictionary, so what perhaps we will get, so that fuzzy means something like confused or not expressed clearly. So then I think participants may be wondering that if fuzzy means something that is arising some confusion or that is not expressed clearly, then what is the need to discuss this topic in such FDP? Actually, yes. So what is the fuzzy logic? Actually, fuzzy logic is built to deal with this kind of situations, which is confused and which is not expressed clearly. Fuzzy logic or fuzzy set itself is not fuzzy. Okay, so it is used. Okay, it has been developed to deal with the situations, which are the situations where it will be much more confused, or which where the informations are not there, precise informations are not available, complete informations are not available, or we are unable to define the situations quite clearly. So that is the need of that we need to discuss, or we need to study this fuzzy set concept. Yes. So as I was telling that, yes, so what is the need that we are wondering that why should we deal with the things that are inherently vague or inherently fuzzy in nature? You know, if I say that one statement that today, the most certain, today, yes, in our real life today, the most certain statement is the uncertainty. The most certain thing is the uncertainty one. So can you imagine something surrounding us which is very much precisely known, which is very much well defined to us? So for just year backs, only 1 or 2 year back, starting from 2019 December, we faced so much challenges with this corona, COVID-19. And to till today, we have so much information regarding COVID-19. But again, we are unable to, I think, find out which is the suitable or which is the appropriate, which is the most well adapted techniques to deal with this novel COVID-19. Because, today China is suffering a lot. Day by day, cases are rising. So many cases, almost all hospitals are full. They are in a very much pathetic situations. Right now, we are a little bit in comfortable situations. But what are the things regarding COVID-19? Whatever we know, that is not enough. What about the information we have regarding this COVID-19? Again, that is incomplete. That is imprecise. Not only on COVID-19. See something, find something surrounding you. You will find out that information regarding that things or regarding that incident or regarding that particular matter, you don't have either the complete informations. Some informations may be missing, something is not precisely defined, and definitely something is there which are not available there. That means almost each and every day we need to deal with this uncertain kind of situations. We cannot avoid that. So how to deal, how to work using these uncertain kind of situations? Yes, then to work or to manage this uncertainty, so fuzzy set or the idea of fuzzy logic will help you. And that is the need of this fuzzy set or fuzzy logic. So often we say some terms that the boy is intelligent, the building is very tall, the garden is beautiful, that place is very much far. Now, once we say that the boy is intelligent, what do you mean by that? What is the definition of intelligent? The definition of intelligent it may be differ with me, whatever I am thinking like intelligent, and also your another coordinator, Dr. Sanjay Kumar Panda, may feel that intelligent is something else. That means what is happening? So the concept of intelligent is differing from person to person. Like once I am telling that building is very tall. So again, the same thing. The idea of tall, how much length or height the building should have to define it tall. Again, that perception may vary from person to person. Then what is the situation? See that exactly what is happening here. So that means we don't have very much precise meaning regarding the intelligent, regarding a very tall, beautiful, very much far. We don't have a very much precise meaning when it may vary from person to person. Then how you will deal with this kind of situations? I am telling the boy is little bit intelligent. The boy is more intelligent. The girl is again much more intelligent. What I mean to say, how you will numerically represent these terms, these linguistic terms. It is very difficult. Now let us see. So these are the example of imprecise terms. And the thing is that we cannot ignore this kind of imprecise terms. In our day-to-day life, we need to work with these imprecise terms. And again, one important example I can tell that yes. So now consider some situation where you want to buy a gift. And suppose you plan to buy the gift of rupees 200. So your budget is rupees 200. Now tell me. So you will purchase the gift once it is exactly rupees 200. Or also you should purchase the gift if it is little bit more than 200, little bit less than 200. What it will do? Yes, the situation is that, so it is not exactly 200. No, it can be 190 to 210, 180 to 225, like that. Now see the situations here. See where is the uncertainty? See. So yes, so that means 200. Once I am planning to purchase a gift for my friend of rupees 200, so 200 is actually something like about to 200. Yes, about to 200. See the term, about 200. And ultimately, here we are getting the introduction of this imprecision and this uncertainty. Uncertainty means here I want to make it very simple. I will try to make it. Uncertainty means either incomplete or imprecise. That I mean to say, that is the uncertain kind of things. Again, see another situation. So if I say that 75% possibility is there that today there will be some rain in Warangal. So what does it mean? I am telling 75% possibility of rain today. What does it mean? Maybe someone will feel, okay, so out of 24 hours, 75%, that means for 18 hours, it will be raining. Remaining 6 hours, no rain. Maybe someone may perceive in that sense. Some others may perceive that yes, in Warangal, what is the total region? 75% of the region, there will be rain. Remaining 25%, no rain. And someone may feel that in the last 100 years, on 70% occasions or 70% days, it was rained. Now see what is happening. So I am telling something, and the idea or the perception is differing from person to person. So this clearly we can find out. So once we say something in our day-to-day life, all these terms are imprecise terms only. Still, I can remember once I felt some power cut in my quarters in the night Warangal. Then immediately I called Dr. Sanjay Kumar Panda. I was telling, okay, sir, I will come within 5 minutes. It may be less than or little bit more than 5 minutes. Now, see, again I was telling the term. That was the imprecise term. So that means we cannot avoid these imprecise terms. In our daily life, you will get so many examples of imprecise terms. Then the problem is that how you will work with this imprecision, how you will work with this incompleteness. You don't need to worry. So here, concept of fuzzy sets and fuzzy logic is there that are going to help us for this situation. Yes, so can we ignore the imprecise terms? We cannot ignore. We cannot ignore. Simply, one more example. A doctor may say, if too much temperature or too much fever or too much pain is there, take one tablet. Now see, too much temperature, too much pain, that means again, the pain, whatever I can adapt, I can feel, and the pain some others can feel again, can feel, so that may be the different. Process controller may say, if temperature is high, then turn on AC. High means what? How much it is high? So all these things, I think, we are getting that terms are imprecise in nature, and simply we cannot ignore these imprecise terms. Yes. So there is a scope of this fuzzy statement, and we need to reason with these uncertain or imprecise statements to come to a conclusion. We are finding so much imprecise terms. Should we leave it? Once something is imprecise, we should stop our work. We should postpone our work. We will simply sitting idle. No work. We cannot do that. That means we need to learn to reason with uncertainty and impreciseness. And that is the scope of the fuzzy set or fuzzy logic. As I was telling, fuzzy set or fuzzy logic itself not fuzzy, but it has been developed to deal with the fuzzy nature. So that is the concept for fuzzy logic. Now you may be wondering that once I am telling regarding this concept of fuzzy set or uncertainty, so we have some well-known idea, very much stronger mathematical concept of probability, where easily we can manage the uncertainty. So uncertainty can be managed with probability. Then where is the need of the fuzzy set? Later I will tell you where is the difference between the probability and fuzzy set. So if you look closely, then you can feel that type of uncertainty that probability manages, that is the stochastic uncertainty. You know, stochastic uncertainty means what kind of uncertainty? That is the uncertainty that over time. All of you know what is the definition. This is the definition I have written for the probability, not going through that. So probability means basically stochastic uncertainty. Okay, so that is the uncertainty over time. But once you are feeling regarding the fuzzy set, this is not stochastic ambiguity. There is no stochastic uncertainty kind of things in the concept of fuzzy set. It is totally different. Here it has inherent vagueness in the definition of the term itself. Tall, see that. Tall, can I say tall, very tall, less tall, medium tall? This is related to stochastic uncertainty, that is related with time. Or I will tell this is some inherent uncertainty, inherent some vagueness is associated with this linguistic term that is known as tall. As I was telling, the perception of tall that may be different from person to person. See, where is the difference? Uncertainty with the fuzzy sets and uncertainty with the probability. Obviously, we can manage the uncertainty with probability, but those uncertainties should belong to the category of this stochastic uncertainty. If those are some another kind of uncertainty, we should take help of this fuzzy set or fuzzy logic to manage this. Yes. So how do we handle this ambiguity? Now let us move into the concept of fuzzy set little bit. I should say Professor Lofty-Zadeh, you know. So Professor Lofty-Zadeh from University of California, Berkeley University, sir introduced the concept of fuzzy set in 1965. And today we are unfortunate. I feel sad to convey that sir has left us for heaven in 2017. So, but what the foundation sir has laid, what is the things sir has given to us? Obviously, we feel that that's all our God-gifted kind of things. Because these uncertainty kind of things would not have been possible without the introduction of this concept of fuzzy set by our Honorable Professor Lofty-Zadeh sir. Here I will tell you something that how sir told the concept of fuzzy set. Let us say. So consider a set that is about to 10. Okay, we are considering a set about to 10, that is A. Obviously, once the set is about to 10, then 10 belongs to the set A. No doubt about that. Okay. Now, this line 9 that may belongs to set A. See that with the degree of belongingness 0.9. See the term, what I am writing. The degree of belongingness 9 may belongs to A with the degree of belongingness 0.9. Also 11 may belongs to A where the degree of belongingness may be also 0.9. 8 and 12, that also maybe belongs to A. But here, the degree of belongingness is 0.7 C. So this is that 10. So here I am considering degree of belongingness for 10 is 1. See, 9. I am considering degree of belongingness of 9 to the set about to 10, that is 0.9. That is 0. Yes, that is considering that is 0.9. Here again I am considering one number 11, and again I am considering the degree of belongingness of 11 to the set about to 10 is 0.9. See what is the situations are going on. If I take another number 8, here I take another number 12, then maybe here degree of belongingness maybe it is 0.7. Here the degree of belongingness also it may be 0.7 like that. See here. The set is about to 10. That means once it is 10, it is degree of belongingness I may consider that is 1. Once it is 9, degree of belongingness little bit less, that is 0.9. Once it is 8, degree of belongingness is more or less, that is 0.7. Actually, whatever I am telling in terms of degree of belongingness, this is nothing but the membership degree. That are important. That is an important idea of fuzzy set. Membership degree. You know, in simple set, so that may be an simple set. 8, 9, 10, 11, 12. Simple set, that may be 8. So, you know, in the concept of a set, what do you normally say? An element belongs to the set or does not belongs to the set. If an element belongs to the set, what is the characteristics function value? That is 1. It does not belongs to the set means it is 0. So simply see that once we are writing simply a set, so we can write the set like suppose 8, 9, 10, 11, 12, that is a set. Here 8, 9, 10, 11, 12 for each and every element. Here what I can tell, characteristics function value is 1. Because these elements belongs to the set. Two concepts. One element can belongs to the set or cannot belongs to the set. If belongs to the set, characteristics function value is 1. That means I can write, yes, 8, it is 1, 9, it is also 1, 10, it is also 1, 11, it is also 1, 12, it is also 1. Since all are 1, that's why we omit this term 1. Okay. But in case of fuzzy set, what is happening? In case of fuzzy set, along with each and every element, the concept of membership grades also will be there. So 8, what is the membership grade? 0.7. 9, what is the membership grade? 0.9. 10, what is the membership grade? This is 1. 11, what is the membership grade? This is 9, and so on. See that. This is the concept or definition simply or an example of a fuzzy set. With each and every element, one membership grade should be added. What is actually the membership grade? As we have written, this is the degree of belongingness. Or I can say a degree of involvement of this element 8 to the set A is 0.7. Degree of contribution of element 8 to the set A, it is 0.7. So this is the membership rate. How much it belongs, how much it has the involvement, how much it contributes to the set, that is the membership degree or membership grade. Here you can see that whatever the membership grade I am writing, I am not writing randomly. This is a specific, there is a specific logic, specific idea how to find out the membership grade of each and every element. Later I will discuss at right time. But the membership grade, whatever I am writing, this is not a random. You can check membership grade of 9 once I am writing 0.9. Can I write membership grade of 8? This is 0.95 or something else. Can I write? Or can I write membership grade of 8 is 0.9 and membership grade of 9 is 0.8? Can I write it? So as per my definition of this fuzzy set, about to 10, that is A. So I cannot write that. That means which is much more closer to 10, membership grade will be more. Which is less closer to 10, membership grade will be less. So that's the concept behind that. See, yes. So here it is written. So in this format also we can write the concept of this fuzzy set. See that. All the elements are there. So these are the elements of the set, and these are the membership grade associated with each and every element. Also, we can write in this manner. So fuzzy set, some elements will be there. Along with the elements, we need to mention the membership grade. In case of a simple set, traditional set, classical set, no need to mention the membership grade. Why? Because it is assumed that membership grade of each and every element in a classical set be 1 only. That's why no need to mention that. So later again I will come to the definition, but I hope that you are getting some idea regarding the fuzzy set. Yes, so that is the Professor Lokti-Jade. Yes. So as I said, that Sir has laid the mathematical foundation for fuzzy set theory, and by extending the fuzzy set theory, Sir has introduced the concept of fuzzy logic. Now, what was the things going on in Sir's mind once Sir has developed the concept of fuzzy logic from the concept of fuzzy set. Already we know the concept of fuzzy set. Next, we will try to explore the concept of fuzzy logic also. Sir has observed that conventional computer logic cannot manipulate data that represented subjective or vague ideas. So he created the fuzzy logic concept to allow computers to deal with those kind of situations. And you will be happy to know that the concept of fuzzy reasoning that I will discuss later is very much similar to the process of human reasoning only. How we are human beings, how we can think, the fuzzy logic is also enabled to think in similar kind of nature. Yes. Now, since we know a little bit the concept of fuzzy set, so we are moving to this fuzzy logic. Yes. As I was telling, computational paradigm that is based on how human think, So how human think, fuzzy logic will try to think in the similar manner. Now, if you can see how human can think, once I'm thinking something, once I'm in my mind, I'm trying to perceive something, what actually I am doing. Our human brain, so once we take some information from the outside, from our surrounding us, information may be imprecise information. Now tell me, we are taking some imprecise information surrounding us from the nature. Okay, surrounding us, some natures are there. We are taking the information in an imprecise manner. Now tell me. But once you will respond, can you respond in imprecise manner, or always you respond in precise manner? See, so that is the capability of the human brain. We can take the things which are in uncertain kind of situations. We adapt, we perceive the things, we reason with the things. But once we respond, obviously we respond with some precise actions. So that is very much important. That means the fuzzy logic concept also should carry the similar kind of task. See the importance between fuzzy logic and human brain. Fuzzy logic also will try to get the things, okay, so which are imprecise in nature. But once fuzzy logic will process of all those things, and in return, it will try to respond, conclude something. Obviously, the conclusion should be some precise actions. Similar. So now we'll try to find out that we'll try to explore that how fuzzy logic is doing exactly the similar thing, how the human brains or we the human beings are doing. So one important thing is that so human brain can reason with uncertainties, vagueness, and judgments. And see, at the same time, computer can only manipulate precise valuations. See that important term. Human brain can reason with uncertainties, vagueness. Okay, but computer can only manipulate precise valuations. See the situations. Then, if we can combine these two things, that will be the wonderful kind of, I think, wonderful kind of things or wonderful kind of invention. Yes, that is the fuzzy logic. Fuzzy logic is an attempt to combine these two techniques. So, uncertain nature of human brains as well as the computing power of computers. So these two things once we are adapting, and as a result, fuzzy logic is coming into picture. So now you can feel that how much powerful the fuzzy logic be. Yes. So as I was telling, that fuzzy logic, that is a precise problem solving methodology. Precise, you cannot say fuzzy logic is fuzzy only. No, no. Fuzzy logic is a precise problem solving methodology. And fuzzy logic differs this from the classical logic. And as you said already, I told that in the classical set, two things are there, either 0 or 1. In the classical set, only two numbers, either 0 or it is 1. That means an element may belongs to the set, it is 1. An element does not belongs to the set, it is 0. There is nothing in between 0 and 1 in classical set, in a classical logic. We can say 0 means false, 1 means true. But fuzzy logic differs from the classical logic. You know, fuzzy membership grade, whatever we have seen right now, so those may take the values in between 0 and 1 also. Those may take the values 0.1, 0.2, 0.3, 0.9. So that is in between 0 and 1 also. Yes. So fuzzy logic, that means differ from the classical logic in the statements that are no longer black, white, true or false, on off. In fuzzy logic, something is there which is in between true and false, in between 0 and 1, in between on and off. So that is the important idea behind this fuzzy logic. Now here I'll try to tell that what are the various applications of fuzzy logic very quickly. You know, so this introduction of fuzzy logic to the engineering world, we witnessed it around in 1990s, basically started from 1985. You know, so even so, whatever today, most emerging technologies today is the age once we are living, that is AI, that is dealt with data science and machine learning. But you know, there is a very much close relations of this fuzzy logic all with the AI, data science and machine learning based approaches. You can find out that we are using fuzzy logic so to manage the uncertainties even in machine learning, even in AI and data science. Many more research works are going on in these directions. Now, fuzzy logic has a huge importance for this low-cost microcontrollers. You know, microcontrollers, once we say that term, you will feel what is the importance of these low-cost microcontrollers. Each and every device, AI-enabled device, almost we are using this concept of microcontrollers. And it is the concept of fuzzy logic is very much suitable once you are discussing with a low-cost microcontrollers. Intel Corporation, they embedded the concept of fuzzy logic, and ultimately they worked with this microcomputer division fuzzy logic based operation. And many others, you see here you will find out many other applications of fuzzy logics that we can use the fuzzy logic for handwriting recognition, hand printed character recognition, voice recognition, for stock trading portfolio based on fuzzy logic, and many other applications of fuzzy logic you will find out. Simply since it is used to manage the uncertainty, so we cannot deny the existence of fuzzy logic. Fuzzy logic is useful almost each and everywhere where the concept of uncertainty is there. So NASA, they have started, they use the concept of fuzzy logic for automated space docking. That was a very much important kind of things. So that fuzzy control system they developed that greatly reduced the fuel consumptions. Once with this automated space docking or aircraft, this fuel consumption is very much important. And NASA studied and used that concept for that purpose. For Canon, also they developed, all the, not only Canon, whatever we are in our today, all our smart devices, we are finding some auto-focusing camera, so much, I think, high capabilities cameras. So each and everything here, you will find out that once it is auto-focusing camera, obviously the concept of fuzzy set should be there inside it. Anyway, so now almost we are getting that what is the idea of fuzzy sets and fuzzy logic, and what is the importance of fuzzy logic, and what are the recent applicability areas of this concept of fuzzy logic and fuzzy sets. So here that was the history of development of fuzzy sets. As I told that in 1965, Sir Jade told, just discussed this concept of fuzzy sets. And around that, I told 1985, researchers and Bell Laboratories, they started this fuzzy logic concept and developed some fuzzy logic based chips. Yeah. So one thing again I should mention here, that exactly again one important paradigm we will discuss, that how the concept of uncertainty is coming once we are solving some problem. See the situations. So we are taking some problem with us. Okay, so problem is a huge problem. Today, all of you are working a little bit on this big data. Huge so volume of data is there. And the problem is very much high, very much huge volume of data, huge volume of informations are there in our problem. So what normally we are doing? So normally we are trying to, once we are going to solve a problem, we are trying to simplify a complex problem. See that once you will run for simplifying a complex problem, easily you can feel that what you may lose. Yes, simplification of complex problem, that will lead to the loss of information. And we need to simplify the problems. Otherwise, we need to do, those who are working with AI, machine learning, data science, a lot more pre-processings we need to do. Once you are doing the pre-processing, maybe there is a chance that you will lose some information. Now, obviously, once you lose some information, so that will raise the uncertainty in your problem. You cannot avoid that. So that is the simplest idea. So that means, so in that sense also, once you have with you a complete data set from all sides, but again, for the purpose of your computation, you are simplifying the complex problem, complex data set. Again, the same thing is appearing. You are losing some information, and that is leading us to some uncertainty, where you need to use the concept of fuzzy set or fuzzy logic to deal with that. Here again, some examples I have given. If I say when you have joined to this FDP, someone will say, sir, almost right time. Someone will say, sir, little bit late. Someone will say, sir, little bit earlier. That means see, whatever the terms you are telling, again, all of the imprecise terms, that means if you want to use these terms in your computations, you cannot avoid fuzzy set. You need to use the fuzzy set to use to deal with these terms. This is the significance of this fuzzy logic. It enables us to model human reasoning process at a higher level. This is used to model the real life situations. It is used as a tool for finding solutions to AI-based problem, as I was telling. In AI-based problem, you will find out in many places the concept of uncertainty may appear, that easily you can adapt the concept of fuzzy set to come out from this concept of uncertainty. So this concept of fuzzy set, creep set, already I told that fuzzy set, fuzzy logic, this is the extension of fuzzy set. Creep set means either true or false. And fuzzy set means it has true or false, means it is 1 or 0. But in case of fuzzy set, it is also there it has an existence in between true and false also, in between 1 and 0 also. See the Krebs logic. See the simplest example of Krebs logic and fuzzy logic. See here. If you consider that 0 to 80 degree Fahrenheit, this is not hot. If temperature greater than 80, that is hot. If temperature less than 80, that is not hot. See the situations. Here hot means I will say it is 1, not hot means I will tell it is 0 or false. Now you tell me, if the temperature is 79.9, will you say it is not hot? See the situation. Temperature is 79.9. But as per the applicability, as per the definition of the Krebs logic, once it is 79.9, then we should say it is not hot. But actually, in reality, it is hot only. That means you don't have the scope to define temperatures much more accurately in the framework of this Krebs set. Yes. The membership functions of a Krebs logic fails to distinguish between the members of the same set. Also, to detect the little difference among the members of different set, as I was telling. Temperature 100, it is hot. 80.1, it is hot. Suddenly, once I am telling 79.9, it is not hot. This is as per the idea of this Krebs logic. Obviously, so Krebs logic will not be useful to deal or to manage with the real life scenario. So we need something else. We need the concept of fuzzy set or fuzzy logic. Now it's the time to discuss in detail. So what is the difference between fuzzy set and probability? Now almost you know the concept of fuzzy set and probability. So now let us see to explore the difference between these two. I will tell you a very simple example. Okay, as you know that fuzzy set and probability, fuzzy membership grade and probability both lies in between 0 and 1. But fuzzy membership grade is not equal to the probability. Now let us see. Suppose I will give you 100 glass of water. Okay, 100 glass of water I will give you. And then I will tell you that drinkability of probability or probability of drinkability is 0.95. And at the second statements I need to say, membership grade, fuzzy membership grade of drinkability, it is 0.95. Again, I am repeating. I will take 100 glass of water. Two statements I am telling. Probability of drinkability of water on all those 100 glasses is 0.95. First statement. Second statement I am telling. Membership grade of drinkability of water on all those 100 glasses, 0.95. Now tell me, which glasses you will prefer based on the concept of probability or based on the concept of fuzzy set? See the situations. If you are unfortunate enough and if you adopt the concept of probability to select a glass of water for you, which will be much more safe for you, drinkable for you, and if you are unfortunate, then maybe you need to take the glass of water which is not pure at all, if you select the concept of probability. Because once I am telling the concept of probability, that means 95 glasses of water is fully drinkable and remaining 5 glasses of water are not drinkable at all. And if you are unlucky, if you are unfortunate enough, you will select that glass only which is not drinkable. So this is the problem with this probability. But in case of fuzzy set, what will happen? All of the glasses, 100 out of 100, purity level or drinkability level, membership grade of drinkability level is 0.95. That means all of the glasses, 100 out of 100 glasses of water are almost drinkable. 0.95 means almost drinkable. That means if you are unfortunate enough, again, there is no issue. You can randomly select any glass and that will be safe for your health. So that is the math. That is the thing that I think fuzzy set is very much important rather than probability. But we cannot say, if you ask me, sir, which will survive, which will vanish, I will say, I will must answer that fuzzy set and probability has their different perspective. Both they will survive. Fuzzy set and probability, both they will survive years to come because they have some different perspectives for the different problems. Yes. So probability means the water is drinkable or not. But fuzzy set means it is more or less drinkable. Yes. So see. So this kind of concept, more or less drinkable. But here in probability, it will give you that liquid is either drinkable or not drinkable like that. Now, these are some real life applications. Once we are discussing the concept of fuzzy set or fuzzy logic, washing machines, air conditioners. Today, it is the fuzzy washing machines. Today almost we have intelligent or fuzzy washing machines. That means once you will give that, I think, cloths inside that washing machine and powder washing powder you are giving, then ultimately how much time it will take, okay, to make your clothes clean, automatically things will be determined. How it can do that? How it can do that? Obviously, intelligent enough. So concept of fuzzy sets are embedded in the washing machines. This is known as the fuzzy washing machines. So almost all the sectors, either it may be household product or it may be commercial systems, each and every places we may get an applications of this fuzzy logic. So already I have told you the fundamentals of a set, so that I'll once again I'll not repeat. So set means the collection of elements which are not repetitive in nature. So as I said, you can recall that in the concept of Krebs set, so that is the characteristics function. That means a member, a number may belongs to the set, then it is 1, may not belongs to the set. That means 0. So this is the characteristics function value for a fuzzy set. Definition mathematical for a Krebs set. If x not belongs to A, it is 0. If x belongs to A, it is 1. So there is nothing in between 0 and 1. Now see. So this is the classical set, either 0 or 1. Now this is the fuzzy set. See, this is the definition of the fuzzy set. So mu Ax, that means this is the membership grade. What is x? X belongs to the elements. X means the element. So as in the earlier example I have shown you that in the fuzzy set, with each and every element, there will be the concept of membership grade. Membership grade means it is nothing but degree of belongingness of an element to the set, or degree of involvement of an element to the set. We define with this membership grade. So this is the definition for this fuzzy set. So you can note it. So this is the definitions for this fuzzy set. This is the element. This is the membership grade. Yes. Now, in this next 1 hour, so we will move inside this, how to design a complete fuzzy system. We want to design a complete fuzzy system, fuzzy-based system. Now, let's move towards this. So, yes, so we want to define a fuzzy logic-based system. So, again, the same thing I should repeat. Fuzzy logic is not the logic that is fuzzy, but this is the logic that is used to describe the concept of fuzziness. Okay. Yes. So this applications of fuzzy logic, see. So this concept of this fuzzy theory can be applied in many applications, so that fuzzy reasoning, fuzzy clustering, fuzzy programming. Actually, all these are some different directions of fuzzy logic. Since today, this session is entirely on fuzzy logic, so I will try to restrict myself on this fuzzy reasoning part only. Later, if I get some time or if I get any scope, obviously we will discuss these other two objectives. Today, our task is entirely to focus on this fuzzy reasoning. Fuzzy reasoning is also called as fuzzy logic controller. See, very much important one, fuzzy logic controller. Whatever the applications of fuzzy logic you will see, each and every application contains this fuzzy logic controller. Even microcontroller that contains the fuzzy logic controller. We can say this fuzzy logic controller, these are the special kind of expert systems, rather I should say fuzzy expert systems. So once I tell the term expert systems, I feel that you are thinking that something in the systems it is there which will give us some expert ideas or expert result. Obviously, it is very much like that only. So in this fuzzy logic controller, okay, so that has a knowledge base. Knowledge base means what? So we normally consider knowledge base is enriched with some knowledge. Now here, the knowledge will express in using some propositions, using some rule. If this, then that. If this, if clothes are more dirty, then washing machine should take more time. Like that. If number of clothes are less, dirtiness is less, washing machine should take less time. See, so these are the rules normally that we keep inside the knowledge base. And these rules are known as these fuzzy inference rules. And also, so once you that, so see that. So what I'm telling, that in fuzzy logic controller, you have some knowledge base. And in the knowledge base, some kinds of knowledges are there. And knowledges are represented using this if, then, that kind of rules, fuzzy inference rules. So once some rules, some knowledges are there in the knowledge base, that means something should be there who will work or who will fire, who will use the knowledge base as per demand. So that is the fuzzy inference engine. Fuzzy inference engine will fire the rules or will fire the knowledges from the knowledge base to do the intended task for the system. Inference engine. So inference engine will be associated with this knowledge base, and main task of inference engine is that it will fire that particular rules which is suitable to that particular system. So that is the necessity for this fuzzy inference engine. Yes. We use fuzzy logic controller where an exact mathematical formulation of the problem is not possible or very difficult. See the situation. Where you will use this fuzzy logic controller, almost in all the problems where uncertainty is there is no precisely defined analytical mathematical model for that. No chance. There is no precisely defined mathematical model for a particular problem. Then what to do? If it is the precisely defined mathematical model, no need to use fuzzy set, go for probability, other things, it will be okay. But once it is not like that, then it is very much difficult, and you need to use the concept of fuzzy logic controller. So how these difficulties are coming? See, due to the non-linearities, how these difficulties in the problems are coming. Non-linearities, because you are unable to define that variables in a linear manner, in a linear fashion. Once it is linear, it's okay. It is easier. You can adapt any mathematical ideas from, I think, linear programming model is there, the very much important concept of mathematics or a person research. But once it is of non-linear, then how to manage it? Time varying in nature, like COVID-19. So each and every time it is mutating, and ultimately it is making us full. Whatever we are doing in the next month, after some time, we are finding it has changed its nature, and it has made us full, like that. Time varying in nature. Large unpredictable environmental disturbances. Something is there which cannot predict. So what to do that? If you are working with these kind of problems, then obviously you can easily feel, you can perceive that exact mathematical model is not possible. Better to work with this fuzzy logic controller based system. So this is a quick diagram of this, or very brief or precise diagram of this fuzzy logic controller. So that although FLC, fuzzy logic controller will work with imprecise terms. But here I am telling you precise terms, that here I have modeled the fuzzy logic controller in precise manner. That means, okay, each and every modules of this fuzzy logic controller are given here. See, fuzzy rule base number one module. As I told, some set of rules, that is the knowledge base. Some set of rules should be there in the fuzzy knowledge base, fuzzy rule base. Next, inference engine. This is associated with this fuzzy rule base. The task of fuzzy inference engine is to explore the rules, to fire the rules. I will say, later I will show you how to fire the rules in the fuzzy rule base using fuzzy inference engine, which are necessary. Because, in fuzzy rule base, many rules may be there. Suppose 20 rules, not only 20, 100,000 number of rules are there. Is it necessary to explore, to fire, to evaluate each and every thousands rules for your system? No. Your system may be useful for a particular subset of rules. How to fire those set of rules? You need to fire using the concept of fuzzy inference engine only. Next, fuzzification module, very much important one. Whatever the information I am getting from my surrounding, is it fuzzy? Creeps only. You are entering something in washing machine. Is it fuzzy? Your clothes are fuzzy? Or whatever the things sharp you are giving, all these are fuzzy. Nothing is fuzzy. So once you are giving some input from the system, those are Cripps values. 10 number of clothes. Some amount of this powder, washing powder. All these are quite given very specifically, Cripps in nature. Inputs are never fuzzy. Inputs are Cripps only. Then, so based on the Cripps input, they will initiate some conditions. And those conditions need to be converted into fuzzy logics, simply into fuzzy membership grades. See that once again I am telling. So we are supplying some Cripps input to the system. And those Cripps input will be converted into corresponding actions. And each and every actions will be associated with some membership grades. So fuzzification, mainly fuzzification module, the task is there to convert Cripps set into fuzzy set. Simply you can see like that. Fuzzification module. We have the Cripps input. It will generate the fuzzy input for that. From the Cripps set, it is generating the fuzzy set. Okay, next. What is this defuzzification module? That is our module number 4. So in your washing machine, clothes are given, washing powder is given, everything liquid is given, everything is given. Then it is determining the time. Now tell me, the time it will determine, or the things it will determine, that will be fuzzy or that will be Cripps in nature. It will take 40 minutes time. It will take 1 hour, 2 minutes time, like that. All these are Cripps in nature, the output. That means whatever the job, your task, fuzzy controller is doing, at the end of the day, the fuzzy controller should provide some Cripps output. This is the task of defuzzification module. It will convert the fuzzy membership grade into some Cripps value, and corresponding actions will be generated based on that Cripps membership value. That means what will be the movement of your tab, or what will be the movement, how it will work, your washing machine will work, like that. So defuzzification module. So it is from converting fuzzy membership grade into, or fuzzy set to Cripps set. So this is our, we can say this is mainly our fuzzy system, fuzzy logic controller, but this is our Cripps system. This side system, so we can say these are our Cripps system. We are providing some Cripps input, as well as once the task of FLC is over, as a result, we are getting the Cripps output. So that is very much important. So as I told, so this is the fuzzy logic controller. Fuzzy logic controller consists of these 4 modules: fuzzy rule-based inference engine, fuzzification module, and defuzzification module. Yes, all these things I told, the steps of this fuzzy logic controller, that it will take some input. I told the steps for fuzzification. Okay, what is fuzzification? Then what is the inference engine? To evaluate the control rules. Even inference engine is meant for to evaluate the control rules stored in the fuzzy rule base. Defuzzification, as I told, so the fuzzy set is converted into Cripps value using this defuzzification module. See, this is the example of fuzzy logic controller washing machine. See here. Normally we say linguistic inputs. That means what is the type of the dart, dirtiness of the clothes. Once we are giving it, so that is the Cripps input. Fuzzification converted into fuzzy set, fuzzy membership grade. Then this is mainly the fuzzy logic controller. Okay, so here based on the rule base, it is in consultation with the fuzzy inference engine. So it is producing some again membership value, and those membership values are defuzzified. Means again it will generate the Cripps input. Ultimately, it will give you the washing time. So this is the working principle for this washing machine. Now you can see, I think you are waiting to find out, sir, what is the example of some rules, what we can use for the washing machine. See, this is the one rule. If dirtiness of clothes is large, type of dirt is greasy, then wash time is very long. So this is one kind of rules. Okay. A dirtiness of clothes is medium, type of dirt is greasy, wash time is long, like that. So these all are the rules you can consider, which are stored in this knowledge base of this washing machine or fuzzy logic controller. Now, once we are discussing the fuzzy logic controller, there are mainly 2 approaches. One is the Mamdani approach based on the and second one is the Takagi-Sugeno approach. 2 approaches are there. Okay, to explain the concept of this fuzzy logic controller or how this fuzzy logic controller works, mainly these 2 approaches we need to study to know it. Today our task is that we'll go for this Mamdani approach in detail. And Takagi-Sugeno approach perhaps we may not discuss today. Now in this Mamdani approach, very much well-known approach, okay, that follows linguistic fuzzy modeling. That means what? That means it will accept some linguistic terms. You know, I already told you some examples at the beginning of the session, example of some linguistic terms, tall, long, short, like that. And it has the high interpretability. That means it is so simple. The steps of Mamdani approaches are so simple. Even a layman who don't have any concept regarding the fuzzy set, even they can understand the Mamdani approach. And obviously it has some low accuracy. But since interpretability is very much high, that means it is very much popular among the researchers. On the other hand, this Takagi-Sugeno approach, it uses precise fuzzy modeling, very much high accuracy, and low interpretability. It is very much difficult, mostly mathematics, to understand this Takagi-Sugeno approach. Anyway, so we will go for this Mamdani approach only. So see, these are the rules, type of rules we use in the Mamdani approach. These are the 2 rules, R1, R2. If X is A1, Y is B1, then Z, that may be C1. This is a fuzzy set, this is the these 2 input, these are the output, like that. Takagi-Sugeno model, see. So this here output is a function of both the inputs. So it is something different, Takagi-Sugeno model. But in the Mamdani model, again, output simply will explore it in terms of this fuzzy set. But this is some function of these 2 inputs. Anyway, let us discuss, move towards this Mamdani approach. Fuzzy rule base So rule base obviously will use to represent some knowledge. How to represent the knowledge? Once we have some knowledge, to represent the knowledge, we will use this Fuzzy rule base. And this is the general format of Fuzzy rule base, as you have seen. If this premise antecedent, then conclusion or consequent. As we have seen, if dirtiness is more and number of clothes are more, take wash time, more wash time, like that. Yes. Now let's see. One important thing here I will tell. So this is my rule 1, this is my rule 2. See, if X is A, then Y is B, where A and B are two fuzzy propositions. This is known to us. Okay. See, now if I say in rule 2, if X is A naught, then Y is B naught. Now can we find B naught once we know this information? Yes. See what I mean to say here. Check the rule, check this thing very clearly. I am telling if X is A, then Y is B. This is known to us. Okay. And I am asking, you need to find out if X is A naught, then what will be the B naught associated with Y? That you need to find out. Now let me see some example. See, so again, so okay, that is some okay, let me check some example. Yes, see the example. See, so given a rule, if X is A, then Y is B. This is given, and this is A. A and B are fuzzy set only. So this is A, X and Y are variables, input variables. A and B are, these two are fuzzy sets. So this is the fuzzy sets, as you know. These are the elements, these are the membership grades. This is A. Similarly, this is fuzzy set B. These are the elements, these are the membership grades. Now see here. So that means if X is A, then Y is B. This is known to us. What we need to find? We need to infer B naught for another rule if X is A naught. See, where A naught is this. That means you know what is A naught. Then you need to infer what is B naught. How to do that? See how we are doing it. So this is, we can say, this is the fuzzy composition rule. So how we are doing it? Simply here I am writing, this is 5, this is 7, this is 9. Check it. So this 1, 5, 1, 5, minimum we will consider this membership grade, this membership grade. Here we are considering the minimum one. 0.2, 0.6, 0.2. This 0.2, 7, 0.5, 0.2. 0.2, 9, it is 0.4. So minimum, it is 0.2. So in this manner, we are formulating this matrix. Okay. So relation, better not to say matrix. This is a fuzzy relation. So here, whatever we are doing, we are using intersection. Intersection means you need to take the minimum of two membership grades, 1 and 5. We are doing the intersection between 1 and 5. 1 and 5 intersection, this intersection 1 and 5, that means what? 1 and 5 intersection. So here 1 means 0.2, 5 means 0.6. If you do the intersection 0.2 and 0.6, you need to consider the minimum one, that is 0.2. That's why I need to write here 0.2 like that. Anyway, so here these are the relations we are doing. Then this is given to us. How we compute this B naught? Let's see how we'll compute it. Again, check it very clearly. This is called max mean rule. Max mean, fuzzy composition. You see, fuzzy, once we are aggregating something, then we need this fuzzy composition rule. Fuzzy max mean is one of the very much popular and important rule for these fuzzy relations. Using this concept of fuzzy relation, we can take or we can generate or we can solve much more decision-making problems. These are some different rules: minimum, max mean, max product, min max, max max. Normally, we will use this max mean rule for that. Fuzzy composition rule. That means two different fuzzy sets are given. How to infer some separate decision based on these two fuzzy sets? Then you need to use this fuzzy max mean composition, like this problem. These informations are already given. So based on this information, you are generating a fuzzy relation. And using this information and this fuzzy relation, that means now what you will do? You will compose this information, this fuzzy set with this fuzzy relation to differ some decisions. See that? Or to infer some decisions. How I am doing, let us see. These fuzzy sets I need to compose with this relation. How to do? Max min relationship. That means what? Firstly, I'll go for this row and this column. See, 5, 2. Max min. What is 5, 2? 5, 2. Then 9, 5. 5, 2. This is 2. See, 9, 5. This is 0.5. 3, 6. This is 0.3. So all minimum I have taken. Next max of these three values, that is 0.5. Here it is 0.5. Are you getting it? Max min relationship. Next, this row, this column, same thing. 5, 2, 0.2. 9, 0.5, 0.5. 3, 0.5, 0.3. Max is 0.5, this is 0.5. This is called max min composition. See, so using this fuzzy set and this fuzzy relation, after applying the max min relations, we are getting this decision. We are finding what is B naught. That will be the result for B naught. As I was telling, these fuzzy relations we can use in many decision-making problems to solve. Okay, now we'll come to another segment of our discussion, fuzzy systems, basically fuzzy logic system only. Now, at a glance, you can see. So this is the structure of this fuzzy logic-based system. Grips input. This is a nutshell, very simplest manner I am trying to show it to you. Grips input, we need to fuzzify. We will get fuzzy input. We need to do some inferencing along with this fuzzy rule base. We will again, as a result, what you will get? You will get fuzzy output. Next, you should apply the defuzzification module, which will give you the Grips output. So this is a single glance. You can see what is the structure for this fuzzy logic based system. Yes. Now the question is that, so from the Grips input, how to generate the fuzzy output? Or from this fuzzy output, how to generate the Grips input? Many techniques are there. Today I will try to show you some of them. That triangular membership functions are there, trapezoidal membership functions are there, fuzzification. So we will show you something. Yes. So once we are converting a Grips value to a fuzzy value, normally we use this triangular membership function or this trapezoidal membership function. You know, triangle means it is a triangular shape, and this is the trapezoidal shape. You know, in triangular membership function, see that at one point membership grade will be 1. But in trapezoidal membership function, in a continuous range, the membership grade will be maximum. That is the difference between triangular membership function and this trapezoidal membership function. So this is the rule that here some power cut is there. Anyway, no issue. So just will connect the system. Just 1 minute. Just I'll switch off my video to otherwise it will again problematic. Just 1 minute. Let me see it is connected or not. Anyway, so I hope I am audible. So during my presentation, at any point of time, if you feel I am not audible, since it is a power cut once again here, so then please knock me. Otherwise, I will be continuing the presentation. I may not get to know I am audible or not. Once again, let me check the connections. It is 90W only. How it is connected. Anyway, I hope that I am audible as well as you can see my PPT. So we'll continue. So this is the, as I was telling, so this is the triangular membership function that you can compute in this manner. So this is X, okay, this is A, B. So now this is the way for that. Once this at X less than equal to A, that is 0, once this inside this X in between A and B, X in between B and C, then you can take these two rules, these two expressions. It will help you to generate this triangular membership value. And once again, C less than equal to X, obviously it will be 0. That means outside this. So similarly, it is the triangular trapezoidal membership function. Now this is the expression for that. So using this trapezoidal membership function, so from any Krebs value, see here, your X be the Krebs value. So from the Krebs value, you can generate the fuzzy membership grade. So these are the expression for this trapezoidal membership functions. Now here better I will show you some example that how here I will show you some example that how to use this triangular and trapezoidal membership function. Just check it very clearly. So here, so these numbers 25, 40, 48, 55, this is related with the age of some person. And these, the y-axis, so this is the membership grade. Okay. Here I am thinking that 25 to 55, so that may be the range for middle-aged person. And according to my perceptions, 40 means here exactly I can say that person is a middle-aged person. Okay, now tell me. So if I am in this region, suppose I am telling that is nearly it is 38. So once I am telling some age 38, that means it cuts the middle here and young here. That means on the age of 38, that person must be much more middle, because here is the middle. Membership grade of middle will be more than the membership grade for the young. I hope you are getting it. See, once I consider the age of a person is 38, then the membership grade associated with middle, that will be more rather than the membership grade associated with this young. Now see here. So this is an example for this triangular. This is the triangular membership function. Always it's in the shape of a triangle. So as I was telling, at one point, so membership grade will be maximum. And for the trapezoidal, so this is an example of trapezoidal, because in a continuous interval, continuous range, membership grade will be 1, and but for the trapezoidal and for the triangular, at only single point, the membership grade will be maximum or 1. Now see here, so here we are considering that one's age is 55 or more, then the person is old age person. That means if age is 60, then what is happening? Age is 60 means he touches here. That means the membership grade with old of that person is 1. That means that person is old only. But if I am thinking that person age is 48, it touches old here, it touches middle here. 48 means then the person is much more old rather than middle. Check, that's simple. That means 48, it has two membership grade. One is associated with old old, it may touch here, membership grade, and middle, it may touch here. That means once we are considering the age 48, it has two membership grade. One associated with old, second one is associated with young. Sorry, with middle. And membership grade of middle is less, and membership grade for the old will be more. Now, here you can find this value of the membership grade using this triangular membership function, whatever I have shown you earlier. So this is the triangular membership function. So if you put this value here, you will get the exact membership grade. Yes, now we'll proceed towards a quick example. So just give me 1 to 2 minutes. I'll take some water. Then we'll proceed to another good example for that. Just once again, let me see. Okay, it is connected only. Just see the connections. Okay. Yes. So now we are discussing this system. Just see this system. So here we are using these two inputs, X and Y, and one output, that is Z. Now let us assume these are the membership functions. Okay, we have two membership functions. One is low T. This is the expression for that. One is the high T expression for that. Okay. Now let's see. Yeah, see. So once consider inputs, we have two inputs, X and Y. So let us assume that X equal to 3.2. So once X equal to 3.2, see here, then the membership grade corresponding to low will be 0.68. Touches here. Okay. And membership grade corresponding to high will be 0.32. See here, this is the high membership grades or triangle related with high. So that means it touches here, that it is 0.32. All we are getting it from this, I think, from this triangular membership function. Okay. Now, these two are values related with 6.1. Once y equal to 6.1, see, what is the membership grade with this low membership function? What is the membership grade with this high membership function? Here you can directly find, since it is the expressions are given. See here, low T, see. Low T means what? 1 minus T by 10. See here, low X. Low X means what will be there? Then 1 minus T by 10. See, low, that means 1 minus 0.32, it will be 0.68. See. High X, high, T by 10. What is T? T means here X. So once it is 3.2, 3.2 by 10. 3.2 by 10, that means it is 0.32, like that. Similarly, we are finding the membership grades for low and high corresponding to our input variable Y. Okay. Next, what to do? See that. So from this, that means from the input variables, now using the fuzzification module, we have converted the input variable into corresponding fuzzy membership grades. Let's see. Our fuzzification is over. Okay. Let's see. And these are our rule base. Suppose it is given. Rule 1. If X is low and Y is low, then Z is high. Rule 2. If X is low, Y is high, Z is low. Similarly, this is my rule 3. This is my rule 4. Suppose these rules are given for that. Try to get it very clearly. So in rule 1, it is high. Once both is low, x and y is low, rule 4. Again, z is high when both x and y are high. Otherwise, it is low only. This is my rule base, it is given. Okay, next. See. Now I need to do some inferences based on my rules. See how I am doing the inferencing. This is the task of the inference engine. See here. Rule 1, how I am doing. See, let us check it very clearly. Rule 1, x is low, okay, y is low. Check. Rule 1, check. X is low x, okay, 0.68. Low y, 0.39. You may ask me, sir, where you are getting these values, 0.68, 0.39. See here, I am getting these values from my previous slides. Low, 0.68, low x, or low y, 0.39. This is not random. We have some specific this membership function. Based on the membership functions, we are getting those values. Okay, so both 0 values. Then what you need to do? If both are low, then what your rule is telling? Then z is high. See, z, you need to find the high z, and here we will use the minimum of these two membership grade, 0.68, 0.39. That will give us 0.39. You know what is actually the significance of this value? This value identifies the strength of the rule. 0.39 means it is the strength of rule 1. Similarly, you can find out in rule 2. What it was in rule 2? If x is low and y is high, okay? X is low, y is high. Now, see here, low x means 0.68, high y means 0.61. We are getting it from our previous slides, these values, okay? Then, what will be your z? Your z is low. See here, how I am finding the value of z? Low z. See, here I am considering z will be low. Here I am considering the minimum of these two membership grades, 0.68, 0.61. I am getting 0.61. Again, this identifies the strength of this rule 2. Similarly, I am finding this rule 3 and rule 4. See, inferencing. So here based on the values I am receiving from my classification module, my inference engine is working. Here, whatever I have taken, here I have taken 4 rules and I have evaluated or I have fired all these 4 rules for the simplicity. But normally in the rule base, more number of rules will be there, and once you are firing, maybe a subset of rules only will be fired. I hope that up to this point you are getting. Now these are the strength of these rules. So our inference engine task is over. Next, what to do? See. So from here, what you are getting? You are getting 2 high values, this high z, 2 high values for z, as well as you are getting 2 low values for z. Then what to do? That means you need to compose. You need to compose this high z and 2 low z values. How to compose? See. Actually, this is the maximum compositions. So initially we are using the minimum, then we are maximizing the values. This is called as max-min compositional rules. See. Low z. Low means where z was low. Check very clearly. This rule 2 and this rule 3. Z was low. Okay. So that means low z, max of rule 2, rule 3. These two values, these are the strength of rule 2. This is the strength of rule 3. Maximum means this one. Similarly, high z, that means rule 1, rule 4, max of 39, 32. It will be 0.39. Are getting it? How I'm composing? As I was told previously, maximum composition. Initially, we are doing the minimization. Then we are trying to find the maximization. Now, whatever you are getting, we are getting one value for low z, second value for the high z. See, we'll plot it. So this is our low This was the low triangular membership function. Here the plotting will be there. Okay, this is the value for 0.61. So correspondingly, position will be this. And for high, this is the membership grade, and so it will cut this. It will cut this high here only. So this will be the thing. Now let us see. Now let us plot it. Let us plot this. Yeah, what will happen? Let us see what I am doing. So since this 0.61, this is the membership grade associated with this low. That means this part is not required. We may discard this part. Simply I am discarding this part. Are you getting it? Check it very clearly. I am discarding this part. Okay. And remaining things. So this 0.39 associated with this high here only. So that means I will take from this side only. But this part I need to take. This part from this and this I need to consider. Take it here. Yes. So simply I have taken a union. I have taken a union of both these two things. Okay, next what I will do. So next we need to find out that, so we have now the membership grades. Our inference engine task is over. Next we need to do the defagification. Defagification means what? From this Krips output you need to convert, from this fuzzy output you need to convert into some Krips output. How to convert it? So that is the task of the defagification module. So defagification module, a number of defagification techniques are there. So that is center of gravity, max sum, center of sum, many things are there. So today we'll try to restrict ourselves into some of the techniques. Center of gravity. See, center of gravity. So how it will find out? Check it very clearly what I am trying to do. So this is pictorially center of gravity of this this region. So maybe this region. So this is conceptually. I'll show you numerically how to find it out. So this position. That means, so corresponding Krips output will be this one. What is the value of this position? That will be the Krips output for the entire process. So this is the concept we are getting conceptually or simply graphically. Now, how to get it numerically? So this is the expression for that. Here we will not use this continuous region. So I will try to make it much more simpler using some Krips values, discrete values. Yes. So this is the centroid. I will show you. This is the formula or expression for the centroid method. So xi mu xi. Okay, summation of all these mu xi. See. This is the expression for that xi, summation of xi, mu xi, and this is the summation of all this membership grade. Let us take some example. Yes, let us see this. Here it is given very clearly. See. So at this point 0, this is a discrete one. Earlier that was continuous one. So in this 0, 0, see, take it very carefully. 0, membership grade is 0.1. 10, membership grade is 0.1. 20, membership grade is 0.1. That's why I have written in this manner. Okay. Next, 30, 40, 50, 60, membership grade is 0.2. That's why I have written it in this manner. 70, 80, 90, 100, 70, 80, 90, 100, membership grade is this one. Okay, 0.5. So writing in this form. And what will be here? So summation of all these membership grades. 0.1, how much time I have used? 1, 2, 3. That's why 3, 0.1. 0.2, how much times I have used? 1, 2, 3, 4. That's why 1, 2, 3, 4 like that. So here I am finding 67.4 this. So this will be my Krips output. So this is the way we can convert that our membership grade into some Krips values. Now quickly within the last 15 minutes, so I think most of the concept I have covered with this using this fuzzy logic. In the last 15 minutes, quickly I will tell you an application of this Mamdani approach, that is the concept of mobile robot. Now here the consider the control of navigation of the mobile robot in the presence of a number of moving objects. Here we will consider that a robot is moving as well as some objects are also moving. So for the sake of simplicity, here we will consider that only 4 moving objects are there, and each of the moving objects are of equal size and moving with the same speed. Getting? So that we will consider here. But in real life, the situation may not be the same. But for the sake of simplicity, we will work in that manner. See, this is the graphical representation. So this is our robot. Okay. So these are all the objects. Same size, same speed, all they are moving. It is moving in this side, like that. It is moving in this side, it is moving in this side. So what is our objective? So that our moving robot should not make any collision with any other moving objects. So how to avoid the collision? So that we will try to determine using our fuzzy logic controller based system. Okay, so here 2 concepts are there. 2 input parameters. One is the D. D means distance of the robot from an object, and theta means the angle of motion of an object with respect to robot C. D means what? Distance of the object from the robot. Theta means what? This is the angle. This is the angle of C. So this is, yeah. So this is the angle of motion of an object with respect to the robot. Angle of motion of the object with respect to the object. This is the angle of motion of the object with respect to that robot. So this is the theta. 2 parameters. One is the distance of the object from the robot. Second is the angle of motion. So 2 parameters here we will consider. Okay. Now here also we'll see that one should input these 2 parameters. Then based to these parameters, the robot will deviate its path or not. See, our objective is to find out the deviation. Deviation means how much angle the object, the robot should deviate so that there will be no collision. Okay. Yes. With respect to most critical object, it will output deviation. Object should deviate from the robot should deviate from its path so that it can avoid some collision with that particular objects. Okay. Again, for the sake of simplicity, we will assume a range of values. Distance, it will be from 0.1 to 2.2. Okay. Luckily, again, power came. Okay. So it is in meter, and theta, we will consider the theta value from -90 to +90 in this range. Okay. So this is our assumption for that. Now let us see. See. So as I was telling, that entire concept now I'm going to implement using this fuzzy logic based controller. Yes. So here we'll consider some linguistic states. As you know, the Mamdani approach always works with these linguistic terms, linguistic fuzzy variables. Here, for that, how to represent the distance, we will use these linguistic terms. Vn, very near, Nr, near, Vf, very far, Fr, far, like that. Distance. To represent the distance, we will use these 4 linguistic terms. And to represent the angle, both for angular direction and for the deviation of the robot, angular direction of the objects as well as deviation of the robots, we will represent using these 5 linguistic terms. LT stands for left, AL ahead left, AE ahead, similarly these 2, ahead right, right. See the fact. So these linguistic terms I am using to represent the distance as well as the angle, both for the angular direction of the objects as well as the deviation of the robots. Now, see, this is very much important one. See here. Let us see. So once the distance of the robot from the object, from a critical object is 1.04. See here. Here I am finding this is 1.04. Okay. Object, distance of the object from this critical object from this robot. This is 1.04. Once the distance is 1.04, that means it touches this triangular membership function here only. That means what will be the value for that? It will get a value for this near. So near linguistic terms, NR, NR stands for near. So near linguistic terms, that means, so it will get some value here, and also it touches the axis far here, near and far. So that means, so near and far for these two linguistic variables, we'll get some fuzzy values. Getting how to convert the linguistic variables into fuzzy values. So we are getting the fuzzy values corresponding the linguistic variables. Simply, if we consider that angle, so that, as I told earlier, that angle, yes, for both for the angular direction and for the deviation. So if we consider the angle, suppose angle be 30. If the angle be 30, then what will happen? Let us see. Angle, which angle I am considering? This angle I am considering, this angle. So here the angle is, suppose it is 30. Okay. So if it is 30, that means, so here it may touch both this ahead and ahead right. Ahead and ahead right in this position. That means the fuzzy membership grade with these linguistic terms ahead and ahead right will be this one. Okay. So that means using this triangular membership functions, here I am trying to find out the membership grade associated with these linguistic terms based on the inputs. Okay. And deviation. So this is our objective. We'll try to find the deviation of the robot. Okay. Let us proceed. So these are the fuzzy rule base. See here. Fuzzy rule base. So here, so this is represented in terms of a matrix. We'll say in terms of some relational matrix. Okay. So how it is? See that. So if it is very near, and it is left, see that, as I was telling. So if the object is very near, and left, and angle is left, so that means, so ahead. So that means the deviation of the robot should be ahead. Let us check it. So these are the rules I have formulated. Very near, left, angular direction, deviation of the object should be ahead. If it is very near, ahead left, so that means the deviation of the robot should be ahead right. If it is very near and this is ahead, the angle is ahead, angle of the object with the robot is ahead, that means the deviation of the robot should be this ahead left. So these are the rules I have formulated. These are the 5 linguistic terms associated with the distance. These are the 5 linguistic terms associated with the angle. So how much rules are there? We will find out total 20 rules are there based on our inputs. Okay. Now let's see. As I was telling, so these are the rules. 20 rules are there. Rule 1, distance is very near, angle is left, then deviation should be this. Rule number 20, distance is very far, angle is right, deviation is ahead. Getting? So these two are the inputs and this is the deviation with the output. Okay. Now let us come to the part of fuzzification. Already I told it, fuzzification, that here we are considering the object O3 with the critical object. So we are finding that we are assuming that there is a chance robot may collide with O3. Okay, others we are not considering it. Next, so here we are considering the distance of that particular object 3 with that robot is 1.04 meter, and angle of that object with the robot, so this is 1.04, and here we are considering this is 30. So these two things we are considering. Now we have to decide the deviation delta of this robot as an output. So what will be the deviation of the output? Here we are assuming that robot is moving, robot is supposed to move in that direction. This is the direction that robot should move. But if in that direction robot is moving, obviously there is a chance of collision. So we should find out how much will be the deviation of the robot to avoid any collision. See, so already I told that using this concept of these membership functions, so we are getting the membership grade. So we are getting the membership grade corresponding to that linguistic terms. Okay, as I was telling that the 1.04 may be called as near or far. 1.04 check. So this is the near triangular membership function and this is the far membership function. So these two membership functions it is touching here. And here angle theta 30 can be declared as either ahead or ahead right. Check it here. So if I declare this is 30, so it may be associated with this ahead or this ahead right. That means see here. So we will work only on this near and far. So these two linguistic terms as well as ahead and these linguistic terms. I think so. This along with this this is ahead right. So these four linguistic terms only will be there once we will proceed further. Now see very carefully. So this is the fuzzification of our input. So I will not go into detail. So due to this x, once x is equal to 1.04 meter, so then what will be the membership grades associated with the near linguistic terms associated with far. So this will be the membership grade of x associated with near. This will be the membership grade of x associated with far. These two membership grades we are computing based on the values of x. And these two membership grades we are computing based on the input values of y. As I was telling, so this is this touching here. That means we need to compute this ahead and ahead right. Okay. Next, what we are doing? Now, this is here actually some noises are coming from the participant side. So I will request the participants to please mute your microphone. Otherwise, I'm finding it difficult to share my thoughts. Please mute your microphone. Yes. Yes. So now this is fuzzification of input. See that. So here actually based on the rule of similarity, principle of similarity, here I have computed the values. What about the membership values I was showing you that how these membership values is computed, how this is computed. You can compute using the triangular membership functions. Here again I have given you another rule, that is the principle of similarity. Here also we can compute in this manner. Ultimately, so we have got that particular 4 fuzzy values for those linguistic terms. Then what we will do? So that means fuzzification module is over. So we will go for this. We have this fuzzy rule base already we have built up. Now we have also developed the fuzzy values corresponding to Krebs input. Next, our task will be assigned to fuzzy inference engine. Let's see. As I was telling, this is the fuzzy rule base. Now, if you look closely, only these two linguistic terms we need: near, far, and this ahead and ahead right. Check it very clearly. Here, near, far, ahead, ahead right. Other terms, linguistic terms are not required. That means, so only if we do, that means only these things. I think yes, this and here and here. That means only these 4 rules we need to evaluate our problem. See here. We may have a number of rules in our rule base, but here inference engine, now we will explore or evaluate only these 4 rules, okay, to solve our robots related problem. Check it very clearly. Yes, so as I was telling. So only these rules will focus. Remaining rules we are not required. Okay. So as you know, what is now rule 1? If distance is near, angle is ahead, then deviation should be right. So this is we are getting from the rule base. Okay, and these 2 inputs are given. Next, as per our concepts, what you need to do? You need to find that what is the strength of each and every rule. Next, we'll proceed. See here. Similarly, the earlier examples, what we did? This is the strength of each and every rules. How we are finding? Check it. Minimum of membership inner, membership ahead. See here. Membership associated with near, membership associated with ahead. This is X, this is Y. So if you look, that means, so this your mu inner, that we got this value. Mu ahead, we got this value. So these all we computed in the earlier step. So that means we will calculate a minimum of these two. So that will give us 0.33. So similarly, you can find in this manner the strength of the other rows. Similar manner, you need to find out the minimum of those two membership grades where you have calculated in your earlier step. Okay, now here one important task is there, that in practice all rules which are above certain threshold value that will use for the computation purpose. Now we will find out which is the threshold value. Here this is the, I think, task of the fuzzy programmer, that we need to find out which is the threshold value for that. Here for our simplicity assumption, we will consider threshold value be this. That means, so these two rules now we will consider for our computation. So this R2 and R4, since this is above this threshold value 0.34. Okay. Next, what you will do? So next, so we need to that you have seen. So that means we are getting to membership grade. So we need to compose, and ultimately after composing, so we should get some creeps output. So how to do it? How to get that? Okay. So anyway, so this is the way. So here I will show you. So what quickly I will show you what I am doing here. See, for the mobile robot. So this is for robot 1. This is for robot 2. I have plotted that those two rules, whatever I consider for computation, plotted in this graph. Okay. So this is for R1. See that this is for inner. This is for near, and I think this will be for the far, FR, and this is for ahead. Okay, so now if you just pictorially see here, so here we are getting here in this mode. So this is our area we are getting. So similarly, you are getting here in this area. Now, if you I think take the union of all those areas, then what you will get as a result. This is the defuzzification process. Now we are proceeding. See here. See. So see here. So what I am getting. So all four things are there. See that this is right, ahead. Okay, this is ahead, right. This is ahead. So all we are combining. So that means we are making this. I think yeah. All we are combining. That means union operations on all these areas. Here we are considering. Now, as you have seen earlier, I have shown you one defuzzification module. So based on that, here we will defuzzify. We'll take the aggregation of all these results. So here I'll not go in detail. Now here that will be our result after defuzzification. Whatever I have shown you earlier, that center of gravity, COG. So here this will be our result for that. Actually, I am doing exactly in similar manner whatever I have shown you earlier. So see that. So from the fuzzy inference engine, we computed those rules which are of much more strength based on some threshold value. Then we initiated our defuzzification process. And based on the defuzzification process, we are getting some creeps output, 19.59. Here we can say our conclusion is that the robot should move or should deviate by 19.58 degree towards the right. See here, towards the right with respect to the line joining to the move of the direction to avoid collision with the obstacle or with the object 3. Why it is I am telling right? Because this is positive. So that's why I am telling this is right. If it is negative, that means that would have been left. So see here. So how important it was that to find out that what will be the deviation for the robot based on the inputs when some objects are moving. Okay, so that using the fuzzy logic controller, we computed what should be the required deviation of the robot so that we should avoid some kind of collisions and our robot navigation should be smooth enough. So this is a very, I think, important application of robot navigation using this fuzzy logic controller. And actually in real life, all objects are moving and in different speed. Size of objects are very much different. So actually once this is the fact, then the things or the logics will be much more complicated. But again, that we can solve using this fuzzy logic controller based problem. Okay, so now thanks to everyone, particularly thanks to the participants for listening me in this one, I think, last 2 hours. So now I would like to take some questions from the participants. So if there are any questions,